Hey there, and welcome. When we think about our bones, we usually think about calcium, maybe drinking milk, and trying not to break anything. But the real story, the one about what truly makes a bone strong or weak, well, it's so much deeper than that. Today, we're going to build a blueprint to understand it all. So, let's just kick things off with a big question. What really makes a bone weak? It's not just about a single crack from a fall. The weakness, the real problem, often starts way earlier, down at a microscopic metabolic level. And the answer, honestly, is way more interesting than you'd probably guess. Okay, let's dive into this. To get a handle on bone weakness, we've got to look past the idea of a simple fracture. We need to focus on the underlying conditions. And that's where we're going today, exploring a whole group of conditions called metabolic bone disorders. At its heart, a metabolic bone disorder is, well, it's exactly what it sounds like. It's a problem with the metabolism of your bone. This means something has gone wrong with the fundamental processes, with the very building blocks that create and maintain your entire skeleton. It's not about an outside injury, it's about a problem inside the factory. So, to figure out what goes wrong, we first have to understand what right looks like. We need a blueprint for a healthy bone. And you shouldn't think of a bone as just a simple, solid stick. Oh no. It's a complex, living structure, and it's built from three absolutely key components. And this right here, this is our mental map for everything we're about to cover. I want you to imagine your bone is a building under construction. First, you've got the mineral component. Those are your hard bricks. Then you've got the organic matrix. That's the flexible steel frame of the building. And finally, you have the cells. That's the construction crew, constantly doing repairs and maintenance. Bricks, frame, and crew. Got it? All right, so using that blueprint, let's see what happens when one of those components fails. We'll start at the most basic level. What happens when the bricks themselves start to crumble? This is all about problems with the mineral part of the bone. These bricks are the inorganic mineral in your bones, mostly something called hydroxyapatite. This stuff is what gives your bones their incredible hardness, their ability to bear weight and withstand pressure. Without strong bricks, the whole structure just gets soft and unstable. And when this specific component fails, when that mineralization process goes wrong, it leads directly to disorders like rickets in kids, which can cause those characteristic bowed legs, and osteomalacia in adults. The bricks are essentially soft, and you end up with weak, distorted bones. But, hardness isn't everything. What if your bricks are perfectly solid, but the building's underlying frame is weak? That brings us to our second key component, the organic matrix. This is the steel frame of our building. It's the organic part of the bone, also called the osteoid, and it's made mostly of collagen. This frame is what gives bone its flexibility, its tensile strength, that ability to bend just a little bit without snapping. See, a bone that's too brittle is just as dangerous as a bone that's too soft. And when this organic frame is defective, you get a totally different set of problems. In scurvy, your body can't produce collagen properly. In osteogenesis imperfecta, you might know it as brittle bone disease. The collagen you do make is faulty. The bricks are there, but the frame they're built on is fundamentally flawed. So, we've covered the bricks and the frame, but what about the team that actually puts it all together and keeps the whole structure in good shape? Let's talk about what happens when the crew starts to malfunction. A lot of people don't realize this, but your bones are not static. They are alive, constantly being broken down and rebuilt in a process we call remodeling. And that is the job of the crew. You've got osteoblasts that build new bone, osteoclasts that clear away old bone, and osteocytes that basically manage the whole project. Keeping that team in balance is absolutely critical. And this really shows how a problem with the process can be just as damaging as a problem with the materials. When this cellular crew goes haywire, you get disorders like Paget's disease, where the remodeling is just chaotic and disorganized, or osteopetrosis, where old bone doesn't get cleared away, making the bone super dense but also incredibly brittle. The crew is working, but they're not following the blueprint anymore. Okay, so we've established a pretty clear pattern here, right? A specific component, the bricks, the frame, or the crew, fails, and that leads to a specific type of disorder. But there is one major condition that just completely breaks this rule. Let's talk about osteoporosis. So here it is. This is the crucial difference. Unlike all those other disorders that target either the bricks or the frame or the crew,
Osteoporosis is a total system failure. It's a disease where you lose both the mineral bricks and the organic frame at the same time. You don't just have less bone. The bone you do have is compromised in both its hardness and its flexibility. It's like losing the entire building, not just one part of it. So, let's wrap this up and look at our final blueprint. The big takeaway here is to think of bone as a system with those three parts. You've got the mineral bricks for hardness, you've got the organic frame for flexibility, and you have the cellular crew doing the constant remodeling. Most disorders pick on one of these specifically, but osteoporosis, that's the big one that affects both the bricks and the frame, leading to a massive loss of bone quantity and quality.